So, let's chit chat about that assignment from yesterday. So, here's the fundamental difference in terms of a whole bunch of different things, whether you're titrating a strong acid or you're titrating weak acid. Okay, and it even starts with the formula. So if it's some weak acid, like a number one, you have benzoic acid, okay, you have a Ka value. So from a perspective of how it exists in the beaker, okay, so you're going to have this beaker, you're going to add sodium hydroxide to it. So even how you write the formula, you need to write that in the molecular form because that's how it's existing. It's a little bit of an ionized, yeah, maybe 3 out of 100 are separated into the hydronium ion and the anion at any given point. The vast majority of them is existing as the molecular form. So you're still going to get water and the anion. Okay? So if it's a weak acid, that's how you need to understand. Oh, this is the molecular form of this. Now, if it's a strong acid, like on number 2, then you really don't even care about the anion because the only thing that's going to matter is the production of water. Now, is the anion going to be there? Yes. Do we care about it? No. Because here's what's the difference is that if it's a strong acid, that anion is not going to ever react back with the water because if it's a strong acid, it has an incredibly weak conjugate base. Okay? That's what makes it a strong acid because it doesn't want to take that proton back. So this is important when you get down to on these questions when it's completely neutralized. So like on number 1, when you get to E, okay, so whether you work in millimoles or you work in moles, so on 1E, this is when this thing is completely neutralized. Okay, the millimoles of your acid equal the millimoles of the base. So here's what's important on this one, is that when you get 20, and again, you're not going to have this on the test, but you need to understand the concept. So what's going to happen on E is that you have that anion when it's completely neutralized, and this only happens when it's completely neutralized. That anion is going to react back with that water. You're going to reform the acid, and you're going to generate some hydroxide ions. So in this situation, that anion is acting as a base, and it acts as a base because it's the conjugate base off of the weak acid. So this is like a circular logic thing. You go, oh, what makes it a weak acid? It has a strong conjugate base. Oh, you take a strong conjugate base, you put it in water, it reacts with the water to reform the acid, and you generate hydroxide. And you know this is generated because of the fact that you're going to see the pH go up, which I'm going to show you in lab mixer with ammonia. Okay? So if you have something acting as a base in water, here's how you know it. The solution turns basic because the byproduct of that is your hydroxide. So when you get to one like E, there's a couple of steps that you need to do. First off, you need to write that reaction. It says, okay, here's my secondary reaction. That anion is going to react with the water to remake the acid and the hydroxide. The other thing that you need when you set up that secondary Rice chart, okay, is this. You need the molarity, not the moles, not the millimoles. You need the molarity at that point. So you need the concentration of that anion in molarity. Okay? Now you're back to the molarity side of the coin. So like on 2E, that molarity should be 0.067. Okay, so that should be the initial concentration of this anion. This becomes 0, minus X, plus X. This becomes 0.067, X and X. Okay? That's that secondary reaction. So with that secondary reaction, because of the fact that this is acting as a base, now you need that Kb value. But you're not given the Kb value. But how can you find the Kb value?
Ka, Kb, 1.
Yeah. You know Ka times Kb equals 1.0 times 10 to the negative
autoionization of water.
Autoionization, which is not water. Okay? So then you can find the Kb value. Now here's the third big step. So there's 3 steps when you get to this point when you completely neutralize a weak acid. The first thing that you need to do is realize the secondary reaction is going to take place, and you're going to generate hydroxide ion. The second important thing is that you need to find the molarity at that point. Okay, so you need to take the moles or millimoles, depending on how many zeros you like to write, and divide that by the total volume. Get molarity. That's the second big thing that you need to do. The third big thing that you need to do is find the Kb value by taking the Ka and dividing it by 1.0 times 10 to the negative 14th, that autoionization constant. So that's going to be x squared over, in this case, 0.067. So here's the fourth big thing that you need to realize. Step number 4. When you get x, are you finding the hydronium ion concentration or are you finding the hydroxide ion concentration? Hydronium or hydroxide?
Hydroxide.
Hydroxide, because you're generating hydroxide. So this X is your hydroxide ion concentration. It is not your hydronium ion concentration.
That's what I meant. Sorry.
Okay. Let's go.
Because it's Kb.
All right, I got you.
I got
You got me? All right. So when you take the negative log of this, what are you getting?
POH.
POH, subtract that from, you get your pH. Okay? So, let me give you some hints. So, on number 1, your pHs should range from about 2.5 up to about 12.5. Okay? Make sure that you have 2 decimal places to the right of every pH. Okay? Not 3, not 1. 2. On number 2, you're titrating a strong acid with a strong base. Now, here's what's different. Okay? When you get to D, and you've generated that chlorous ion, ClO4, and that's in the presence of water, do you reform the acid, ClO4, and hydroxide?
No.
Do you need to do that step?
No.
No. Why?
Strong acid.
The strong acid, which means it has a
Weak conjugate.
weak base. There's no need to do that secondary reaction. Do you neutralize it? Yes. Is the anion in the water? Yes. Is it going to do anything? No. And here's how you're going to know that here's how you know you started down into a rabbit hole of pain and suffering. Because eventually, if you try to do this, like, oh man, okay, I remember what Burkamp said, man, we got to find the Kb value. But to find the Kb value, what do you have to have?
We ain't got no Ka.
You ain't got no Ka. God, it sounds like
It sounds correct.
Englishman's physics or chemistry. Ain't got no Ka. It sounds like you ought to be like sitting on the side of a road, begging for ain't got no Ka. Help a brother out. Ain't got no Ka. So at this point you would realize, oh man, I have screwed up because I can't find the Kb value. You can't solve it if you try because you can't find the Kb value. Okay, so your answer to 2D is just 7.
Yeah.
That's it. It's just 7. Are there anions in the water? Yes. Does it matter? No. Okay. On number 3, those ranges should also be from around, this is an ish, around 3 to about 12. Okay? That's a huge-ish, but that should be the range on number 3. Lowest pH is around 3, the highest pH is around 12. Now, let me give you this hint. And this is just random, there's no hidden meaning to it. But your answer to 2E should be the same as your answer to 3F. So if those are the same, odds are you did it right. If they're not, might reconsider some life choices at this point. Okay. Anybody have any questions? We're good? Once, twice. So, get that handed in. Stop, number 10.